Welcome to a scary talk. When this talk is finished, you won't want to be a programmer anymore. You will shut your laptop and you will never ever write code again. Or maybe there's light at the end of the tunnel. So I'm going to talk to you about that, Java vulnerabilities. It's a hot topic, and I'll explain why it's a hot topic, and we'll cover some examples, and we'll talk about the bad guys and how they get in, and just go around the edges, okay? And I'll talk about some boring bits as well. So anyway, start with me. I want to look up. So I work for IBM. I work on JVMs. I've done 20 odd years doing JVM development. That's my primary job. But I've also done other things in my career. And right now, mostly what I do is this, is I come out and talk to people, which is really cool. So I get paid to come and talk to you guys. So this talk is about Java vulnerabilities. Okay. We're going to talk about the boring bits, how we manage vulnerabilities, what are attack vectors, these sorts of terms, the boring bits. We're going to do the scary bits. There's lots of scary bits, and I hope I'm going to convince you that when you walk away from here, there's a couple of things you're going to have to do, and you will have an understanding of why that is important and why you as a developer should care. And because we're developers, we'll put some code in there, but not very much. Okay? So we'll start with this one. So we use the word vulnerability. You know about it. You've come here. Java vulnerability, it means something to you. The question is, what is a vulnerability? It's a sort of null word. It's like security. You go, what does it mean? Have you got security? Yes. Okay, but, what does it mean? So, let's start with an example. This is a fix, a git diff to a bug. Okay? You can see it's a one-line, it's a 2-character change. This 2-character change was in Java math double, parse double. This is a fix to a little tiny bug that if you gave it this number at the top, then the parser would go into an infinite loop and it would hang. Okay? And you can see it reported 2001. It's a very old bug. And it sat around for a long time and nobody paid any attention. It's just a thing, it's just a bug. And then it turned out to not be a bug anymore. It turned out to be a major security vulnerability. Because it turns out that if something hangs, and you can make it every thread in a system hang, that's a denial of service attack. Okay? And it turns out, and I'll explain why in a second, it turns out that at the time, a few years ago, when this came out, every single Java web server was at risk. Because the attack that could be done didn't even involve any security, it was just prod. Example, find an HTTP header which has a double in it, send it the bad number, send it again, send it again, send it again, hang all the server's threads. Okay? Because it turns out, if you look at the spec for accept, or for any of these headers, one of the things it's got in it is float. Okay? And the float is this C point. So the spec says, when I send a header, when I do a put or whatever, I send up a header, I can put a floating number in. Okay? Where does it get used? Well, it gets used in all sorts of places. So if you're taking down audio from a web server, you might want to set the pace at which the audio comes down. And so there's lots of places where you're going to send up floating point numbers. So it's a reasonable thing to do. Okay? And it turns out that if you did that, but in fact you replace the 0.2 with the magic number, then the server would hang. And lots of people did this, right, to your favorite server because it's to the web server, it's on the incoming request. There's no security involved because you haven't even had a request. The request comes in, does the parsing, it hung everything. Right? This thing was discovered in 2001, so luckily it's all pretty much fixed now, and you can go read all about it. But basically, we had, once it became known this was possible, everybody had a go. 15-year-old kids were having a go at bringing down web servers because it was easy, because everybody could do that. Right? So, when we talk about what the vulnerability is, one of our descriptions could be simply it's a bug which somebody can exploit. Okay? That seems reasonable. How about another one? Okay. How about this? Can you see the bug here? There's a massive exposure in this piece of code. No, because what's missing is missing. There's error code that should be in there. And it was the fact the error code was missing that this thing could be exploited. Okay. Bear in mind, think about the first bug, 2 characters. Here's another example where something's not there. So it'd be really hard to review that. So this one is sort of the canonical example that we use nowadays. Okay. So let me walk you through it. There's a link at the top there that you can use to go read all the gory details. Normally we won't communicate the details because that's a bad thing to do, but this one was so exciting and it got covered by people. So top blue box is another header, content type. And you can see there's all this GORP in there, all sorts of stuff, right? And you can see that tucked away at the first line it says multi-part form data. Okay. Now this is an input coming into Apache struts. Apache struts does the content type contain the characters multi-part form data? And it went, yes, it does. So it expects the body to be in the right format. Okay, it goes to do that. It fails. So the Apache struts coders decided that they should be reporting nice error messages. So when things don't work, give back nice error messages. Unfortunately, as part of the error processing, the content type script up there got identified as what it is. There's Apache struts has this scripting language called OGNL. So as part of the error processing, to report back there was something wrong with it, it got executed. And guess what you can see? Java lang runtime get runtime exec. Okay. This is a big hole because of the same reasons before. There's no checking at this stage. It's just stuff coming in. You're validating. Is it any good? No. Bang. Any idea who this might be? No? Equifax. Poor guys. They were unfortunate that they got hit by this and for other things which we'll talk about, they didn't come out with the greatest reputation out of it. But that's another bug, right? It's not the only type, but it's a coding bug, okay? There are lots more complicated ones. There are things like deserialization vulnerabilities. So how many of you are Java programmers? Okay, let's ask, who are Java programmers? Just checking. If you're all JavaScript programmers, let's go. Okay. How many of you use Java serialization? Okay, so if you're a Java programmer and you're doing anything of any reasonable usage, you're probably using serialization if you don't. A classic way of getting into the system is to break into protocols and use Java serialization to get you to run code. And what they do is they look at what's on your class path, which they can find other ways, and they will try and get you to run code. But you're going to say, my code doesn't run code. I don't do these things. But your class path contents probably does. And the question is, with serialization, you can construct these sequences of calls, and it's called a gadget chain. And these gadget chains can be used to make code that you have installed, it's not code you're downloading, it's code you have installed, to do things that perhaps it wasn't intended. Okay? And there was one with Apache Commons had this bug in it, and it was exploited everywhere for exactly the same reason as all these others. It was just very easy to do. So gadget chains look like that list on the left. At the top is object input read stream, and that's, if you're doing any serialization, that's the start. But what people do is they figure out how to construct the data. So the data that's in the serialization stream, it can be manipulated very easily. And one of the things it can do is it is self-defining. So I can start with a class that loads a serialization form that mentions a class that you weren't even expecting to be there. And that class can be coerced to load another class, and another class, another class. And you get these sorts of chains, just random code that's on your class path that gets put together until eventually you hit the one at the bottom, runtime.exec. And serialization is used in all these places, even in places you wouldn't expect it. Java serialization is be used all over the place, in persistence for sure, remote EJBs, etc. Okay, it's everywhere, even in cookies. Because people use Java serialization, take a graph of objects and turn it into data. Fortunately, the data can be manipulated to make your code run badly. That's another style of vulnerability. That's a real gadget chain. Okay? So at this stage, it's worth pointing out that almost all the time, apart from serialization ones, which is the exploit, the actual vulnerabilities themselves are usually very small bugs. 1 or 2 lines, maybe a bit more. Sometimes it's simple things are missing. Exploitation, as you just saw, can be quite complicated, but that's not the point. The point is Java vulnerabilities are simple bugs. And bugs are everywhere. And that means that vulnerabilities are everywhere. So wherever you look, in any code that you've got, it has vulnerabilities. So the thing about vulnerabilities is we have to talk about them and manage them, okay, because they're never going to go away. There's never going to be a point where we don't have them. And because of the way they're being exploited, which I'll talk about later, it's becoming a really important thing for you to be aware not only of the fact that these exist, but also where to go to find out this stuff and how to manage it. Okay. So let's do the boring bits. Let's talk about Java vulnerabilities. Okay. So the good news is there are multiple websites that you can go to get details about vulnerabilities. Because how do we talk about it? Do I go, hey, it's the struts problem, or it's that double float thing? Because if we're having a conversation about it, we'd like to have some standards. And so the standard is called a CVE, Common Vulnerabilities and Exposures, okay? And there are places where you can go find this, but basically there's a couple of canonical sites where CVEs are recorded. CVEs are used for every product, right? It's a common term, it's not just a Java thing. Okay? It allows us to talk about them and share information about them without all the difficulty of trying to explain which one we're talking about. The good news is that you can go to a website, so these websites, and you can go find out what there is. So you can go to CVE and type in some keywords. So this chart's a bit old, but it's irrelevant really about the numbers. So I went this and said, hey, how many Java vulnerabilities are there? 1,761. How many Java serialization vulnerabilities are there? 12. Put anything, Python, PHP, Apache Strut, whatever, and it would tell me. I had this great resource to tell me about all the vulnerabilities that are out there. That's great, because when we talk about a vulnerability, you know whether you've got it fixed or not, because when you installed something, it should tell you what vulnerabilities are being fixed. So you have comfort factor that you know whether or not that vulnerability, a fix that vulnerability exists on your system. Okay? So when you look at them, the words look like that. They're not the greatest words, are they? Right. These are just the extreme ones, the Java serialization ones. But if I pick one particularly, let's talk about that. So there's this CVE. You go to the website and that's what you'll find. Unspecified vulnerability. tells me what version of stuff it's in, and vaguely what it lets me do. Maybe how, like through serialization, but it doesn't tell me any more. Okay. We don't do that. Here's why we don't do that. If I give you public information about how to exploit a vulnerability, if I tell you what the code looks like, then if you're a bad guy, you can go, thank you very much. I'm just going to go create some exploit. So I always say, we don't do this because it's the same as me tweeting about my credit card number and PIN number. Would you do that? Would you meet some random guy on the street and go, here, yeah, have some? No, of course not. Which is why we don't share that information. Okay? It is hidden. It's a bit of a problem because you guys are inquisitive and you'd like to understand. But at the end of the day, we have to make it as hard as possible for people to understand the details because they're going to try and create exploits. Okay? So what we do is we score them. There is a thing called the CVSS, Common Vulnerability Scoring System. It's complicated. On one hand, we try and give you a number so you can assess it. Is it important? Is it not important? On the other hand, we have a vector, which is a series of evaluation points that you can look at to go, oh, actually, it may not be very important in general, but that's something that I care about. It's a style of attack. Right? And we worry about time because vulnerabilities are only vulnerabilities when somebody exploits them. So when there's no known exploit, it may not be particularly important. Right? Or it might be it's a very important bug even without an exploit because we know how much damage it could be. But sometimes vulnerabilities become important because suddenly there's an exploit. And then once there's an exploit, you need to fix it because once there's an exploit, everybody will exploit it. That makes sense, yes? So the vector's got all sorts of stuff in it. Like the complexity of how hard is it to attack you? Do you need special privileges? Does it attack your confidentiality? Does it bring down your systems? Just some assessment so that you know. Okay. All this assessment is based on the idea that you are behaving properly and that the systems that you manage are managed properly. If you run everything with root and you give everybody passwords to all your systems, then forget it anyway. Okay, so this is all the boring stuff, but it's important. So we're assessing these things, we're communicating with you. We will tell you, Oracle, IBM, Amazon now when they do their stuff, Azure, whatever, will be publishing lists of CVEs that are fixed. This release contains information about these CVEs, these fixes. Right? And any of the information, if it's an urgent one, then we tell. Everybody's trying to tell you things. You may not be paying attention, but everybody's trying to tell you. Now, the other way, the other communications thing is you find one. If you find one, and bearing in mind what I said about it being quite tiny, you might not spot it. But if you do, then we'd ask you to report it, obviously. Even if you're not sure, report it. Because the more eyes we have on the code, the better. Better that you report something that somebody says, no, actually, we can't see how to exploit that, rather than you go, no, I don't think it's a problem. Okay? Right? What we'd like you not to do, don't tweet about it. Hey, I found a bug. Look, if you do this, I can bring down the US government. Don't send mails about it. Don't post it on forums. Don't give it away where other people can find it. Okay? And don't sell it to the bad guys, because then you're a bad guy. So we have a scoring system that lets us worry about complexity and impact. We have a process of communicating with you. In theory, we have a process for you to communicate with us. And then the next thing is, the process is, how do we fix it? So the interesting thing, as you might imagine, is there's not an infinite amount of resource in a JVM or any team anywhere to just fix stuff. So the prioritization is as important for the people fixing it as it is for you consuming it. So basically, we look at it from the same point of view. High severity CVEs need to be fixed the next release. Otherwise, it's based on business pressures. Okay. The good news is you get these regular releases of fixes. The advice is that if one day we do an out-of-band one just turns up, hey, you must do this, it's going to be important, and you better put it on quick. Now, how you assess whether that vulnerability is useful or impactful to you is interesting in itself, right? Because you're going to look at it. So if it's in, what did I say here? So yeah, if it's in Java plugin and you're an app server, maybe you don't care. If it's in JAX-P and you don't use JAX-P, maybe you don't care. Okay? But you can go read all this stuff and make some decisions about whether you want to apply it. Right? But you can't see this, but I can. There is a problem with this statement, which we'll go into in a minute. So, vulnerabilities, bugs, design issues in your system, everybody's looking for them. Everybody's looking for them. White hats, black hats, because they're so valuable. There is a continuous arms race going on here to discover more bugs, to create vulnerabilities, and people trying to create fixes. Okay? And you may not see it happening, but believe me, it's happening. Because these guys, when they get in, are going to try and do some really nasty things to you. So they're going to steal your data. They're going to change your data. They're going to go in and just tweak things. You'd be surprised. They're going to crash your systems. They get paid to bring down other people's systems. Competitive businesses may pay somebody to bring down somebody else's business. Okay? They're going to steal your compute power. How many of you run Jenkins? Never used Jenkins or a build farm, build server? Okay. You probably go, I'm really glad that it's running at 100% because that means it's busy. But it might not be busy for doing what you think. There's a classic thing now of people getting into Jenkins servers and using Jenkins to do Bitcoin mining. That's stealing your CPU. So if your system goes down slower, it might not be because of your application. It might be because somebody's got onto your system and stolen your CPU. And then, of course, the other thing they want to do is get into your system and then get to somebody else's to do the same thing. Okay? Right now, though, this is the big thing. The one that everybody's looking for, because it's the most flexible, is what's called RCEs, remote code execution, like the exploit one. How do I get into your system so I can run arbitrary code? Remember that, run arbitrary code. Any code you have installed in the system, I can now get at. Okay? So when you're coming in, the term is attack vectors. Okay? When you start looking at this, it all starts to get even more scary. So what are the basic ways that you can get into the system? So the classifications that we look at are things like this. Untrusted data. Every time you send data out to somebody else, when it comes in, you need to validate it. When data comes into you unsolicited, you need to validate it. And it's not just things like JSON script, JSON data, okay? JPEGs, fonts, jars, anything anybody could upload. Because, and I'll show you an example in a sec, it's really easy to work around some of the restrictions that you think might be there. Right? So here's a really good example. The nice little pretty kitten. Right? This is just pictures, but there was a vulnerability found in some C code runtime. Okay, not Java, in C code, and it used this buffer overflow. And what it meant to do, because it was a bug in the parser, so they managed to insert inside the image, right, some code that could be run. So when you're sitting there and you're going, I'm going to let people upload images, that image will get converted and processed. And if you have this bug, then you're vulnerable. So it's not just images, it's not just JSON, it's any data that comes into your system is possible for being corrupted and exploited. So that's untrusted data. Then there's untrusted code, which is basically the plugin, and web starts, which is why we're getting rid of it. But basically, any way of moving around the security manager to run stuff. Now, untrusted code is usually is delivery of code. The serialization one I told you was exploitation of code you've already got. But untrusted code is, can I get code into your system, right? And there are just loads of ways of doing that, right? The important bit is to understand that it is not just the plugin or the web start, it's in the app servers as well, because it's all about bugs. Okay? The plugin itself has a whole bunch of things which I just won't read. It's just so many ways that we found to get your plugin to run code, right? Not your code, it's just everywhere, so which is why it's going. They are 323 CVEs containing applet. That's a lot. So, it's sort of good this is going away. Another one, cryptographic. So there are two parts here. There's protocol design, and you've probably seen once or twice we've had a few recent large scares around vulnerabilities, which all have nice names, beast, poodle, sloth, you name it, where somebody has realized that the design of the protocol has a flaw. What do you do when your design is broken? When your specification that you're sharing among the world breaks? Right, well, you panic and you create a new spec and you hope everybody will move to it. Okay? So protocol flaws are awful, but don't come up very often. Implementation flaws, a lot more common. That's where people figure out they can break your cryptography by giving you certain sorts of data because they've looked at the implementation, they understand the implementation. Okay? And of course, if they can break your encryption, then they can steal your data. Some of these have been really clever. Some of the bugs have actually got to the point where you can steal the private keys from the server using the encryption. It's just boggling. Okay? And then there's the one that people go, no, this isn't going to happen to me. Local attacks. People get onto your system. We tend not to worry about those when we talk about CVEs because, well, we assume your system is secure. But of course, once I can get onto your system, I can do all sorts of things. I can add data, I can put new classes in your class path, put things in your extension directory. I can change security bits. I can do all sorts of things because I have full access to your system. Okay? And as I said, lots of people go, no, nobody would do that to me. Nobody can get into my system. Anybody seen one of this? Does anybody know what this is? Okay. This is either because you have seen it and you don't want to admit it or you don't know. Okay. So, not that long ago, this little tiny problem turned up and people found out that when they tried to access their Windows system, it said, sorry, all your files have been encrypted. If you want them to be unencrypted, pay me some money. Ransomware. So this example, okay, a ransomware was paying Bitcoin. They use Bitcoin because you can do an anonymous Bitcoin transfer. So it's actually, ransomware is quite prevalent and growing because you can actually exchange money without being, without any identities flowing. This one, or this. I don't know why my name's in the middle of that. That's weird. Anyway, WannaCry. Anybody heard of WannaCry? Yeah, okay. WannaCry. Big one, but not the only one. So last year, 250,000 computers, 150 countries, shut down IBM, India's ATMs, Nissan Renault plants, National Health Service in the UK, okay, all for about $500. That's all they wanted. Okay. Somebody figured out how to talk to these guys, and they said, how much money have you made? And they went, $85,000. Do you think how much it cost the world for recovering 250,000 computers? Okay? And this is through WannaCry. WannaCry is a delivery system that you can buy on the dark net. So I can, using that, I can deliver code directly to your desktop. If I can find a vulnerability, I can get in, I can deliver code. Your server is not safe unless you're very careful, because you're accessing it through other machines. And even when you think it's safe, you should look again, because these things are popping up. But there's another way this stuff gets in, not just through WannaCry. How many of you have ever done this? Who's ever done apt-get install? Who's ever done, what was it, Maven install, npm install? Okay, I'll keep going until your hands go up. We've all done it. We've all done it. It's a reasonable thing to do, isn't it? You want to upgrade your Linux machine, apt-get install. Okay. Who's ever checked the license of the stuff they're installing? Were there any hands? Are you frightened of it? Okay, maybe. Okay. Most people check. Well, I was going to say most people, but you guys are very shy, or you're not doing the right thing. So checking your license is the usual thing, because that's a business thing. Can I use this? Is the license okay? Okay, and we tend to do that. How many of you checked the license of the dependencies of the thing you've installed, or its dependencies, or its dependencies? You know, you do apt-get install when it says to install this, I've got to install another 500 packages, and you go, yeah, fine. You don't check their licenses, do you? Because that's hard work. Okay? And then, how do you check the reputation of the person who's written the source that you're using? No, you don't, because you trust them. One of the things that the reason that we have the problems that we do is because developers are incredibly trustworthy. We just think if it's open source, it's going to be great. We can just use it. We don't check. We don't check the licenses, and we sure don't check whether the guys who wrote those things are trustworthy. We just use them. So our behavior is as much a problem with vulnerabilities as in the code itself. Okay? Because we are targets. If you're a developer, you're a target. You're a target for social activity. Right? Social attacks. There are other people who get targeted. So there's some really classic things, right? So from a social engineering point of view, I'm going to go find out. I'll go read what you think of your manager. I'll go to your Facebook account. I'll find out what you think of people. I know you don't like somebody, then I can get them to send you an email. I can spoof them, right? Maybe you hate somebody. Maybe you're frightened of somebody. All those attitudes that you have can be exploited. Okay? If you're new to a company and I find out, then maybe I could convince you to do something that would be wrong, but you didn't know that because you're brand new to the company. Okay? And if you're really, really busy, maybe the same. Maybe I can just convince you. Maybe that email, that spam mail you got, which was not quite right, but you were too tired to notice, and you just did. Oh yeah, okay, I'll install that. I'll do whatever it says. Okay. And then of course there's the bad guys who are on the inside and go, yeah, I'll make money. I'm really unhappy with my company. Hey, would you like to make some money? You know. But developers, the golden goose. Okay. Here's why. Why are you a good target? Because you know all about the code and you talk about it. You write things in GitHub repos and Git and bugs. You talk about it, right? You have elevated privileges. Normally, you are allowed to do things beyond what an end user would expect to do. Okay, and you are over trusting. You just download stuff. Okay, you just do that. I'll just take it. Great, thank you. How many of you have got a USB key? How many of you have got a USB key? How many of you ever shared it with somebody else? Okay, and then did you throw it away? No. Because you are. Why would I do that? My friend's okay. Yeah, but you don't know about his friends. Right? We have this attitude that everything's safe because we don't see the bad things happening. Okay? Right? And of course, we're ignorant of security matters because it's not our problem. So when I say things like this, the bad guys prey on the weak, vulnerable, and ignorant, and I go, It's us. People go, no, I'm fine. Okay. Okay. How many of you ever Google for things like this? Getting Java to accept all certs over HTTPS. Have we done that one? How to trust an SSL certificate? Yeah. Very trusting trust manager. How to disable certificate validation in, well, I say Java, but it could be anything. How do I turn off the checking? I'm downloading something and it's got a bogus certificate. It's self-signed, so I'm just going to, how do I work around that? Stack Overflow, what do I do? Oh, thanks very much. Right. How many of you have ever written something like this? Java Trust Manager. Yes, thank you for being honest. Look at this, the middle two lines. Is client trusted? Is server trusted? Return true. Right? And this is what people do. It's what developers do to work around the problem of something not working well without thinking about the consequences. Right? We do it all the time. We do it all the time. Right? How bad can it be? So I did a GitHub search for implements trust manager. Okay. How many hits did I feel? Did I hit more than one? Yeah. Okay. Of course I did. 100,000. Look at the words. Okay. Install the all trusting trust manager, the over trusting trust provider, a very trusting trust manager that accepts anything. A very friendly accepting trust manager factory allows anything through. This is in GitHub. Yes, in GitHub. You know those dependencies that you downloaded without checking the licenses? Where does the source for that come from? Mostly it's on GitHub nowadays. So my search covers all the stuff that you're installing. And I'll tell you, this is sometimes deliberate and publicized. Right? Sometimes it's a feature. So, to my a vulnerability is a bug which can be exploited by an attacker, I have to add, it's also a feature which can be exploited. Right? And the problem is, because we don't know a lot what our code does, especially if you inherited code, you don't know what it does, you don't know if you're vulnerable, you don't know what your dependencies do because you just use them. What do you get with your dependencies other than that one line class that does the thing you want? Okay? So we are that vulnerable because we're not paying attention. Okay? So to be clear, bad guys are out there looking at your code and your behavior to find ways in. Why should you care? Why is that important? So let's talk about reality. Talk about the bad guys. Do you think bad guys are lone hackers? Who thinks that the cybercrime guys are 15-year-olds in their bedroom? Anybody think that anymore? Good. No, they're about 16. No, they're still there, but they're organized. In 2016, organized cybercrime became the most profitable form of crime. In 2016, $450 billion as against the drug trade, the illicit drug trade, of 435. Now these are estimates because bad guys won't tell you how much money they made, but they're reasonable, okay? Which of these, cybercrime or drug trade, is going to have the least risk to the criminal? What do you get caught for? Smuggling drugs or hacking some system remotely? Drugs. Which is growing the fastest? Cybercrime. Because it's invisible. Which is the hardest to prosecute? Cybercrime. Because we have no rules, no laws that allow us to prosecute somebody for hacking a government system. The US is quite good at coming off, if they finally find them, dragging them to jail, but it's pretty rare. Okay? Which one of these two is predicted to reach 2100, $2 trillion by end of next year? Or which one is predicted to reach $6 trillion by 2021? Well, look. Here's a little chart. Well, okay. So the words have disappeared. The green line is the drug trade. The red line is cybercrime. Watch what's predicted. Oh, So you know all those movies you watch about the drug trade? Expect to get a lot more movies about cybercrime because it's going to be worth a lot more. All these things about people burying money in fields and weighing it, well, that's nothing because the drug trade isn't predicted to rise much because people know how to manage it and measure it and keep it under control. Not gone, but better than it was. Cybercrime, still out of control. That number equates to this, about $600 for every one of you, or euros, about the same. That's a lot of money. Okay? And that's per person. For us, it's probably more than that. Right? But they're going to take that away. They're going to steal that from all the businesses that you use. They're going to steal it from the banks, insurance companies, the petrol stations, and your bills will go up because they're going to push the money down to you. Okay, so let's talk about how they do it so you can see how this all connects. So it's called phishing, but it's called phishing with an F. And here's how it works. So I go and find a remote code execution. Here's the struts one. Okay, and there's all the CVE, all the details. Look, it tells you what version numbers. Before 2332, before 2510. So I've got the data. So now I need to find a server that's got the vulnerability on, haven't I? So things I can do. I can search for metadata. It turns out that there were some design changes around that lets me work out whether you're likely to be vulnerable based on some files that I can type. So I can go to Google and I can do file type action. Not dark web. Now you guys can go do this straight after. And I do that, and I get 23 million. 23 million servers that have a file where the suffix is of type of action. So I just pick one. Some random travel site. Okay? So what else can I do? So other vulnerabilities. So I found a website. What else can I find out about the website? Okay? So there are some Chrome tools. So I'm not doing this as a demo because just in case. But there's a Chrome tools that you can turn on. Okay? And you can go to the network tab and you can record all the data that you download. Turn that on, you refresh the page, and then you have a look at what you've got. The very first thing, which I've hidden because it's the IP address, so not to embarrass people, hey look, it's got a whole bunch of headers, okay, and response headers. And if you look at that in activation, look, server, Nginx 1.12.2. Hey, thank you. Okay. What vulnerabilities does Nginx 1.12.2 have? I go back to CVE website and I put in the search. You see the search, Nginx plus 1.12.2? I get 2. So now I've got 2 vulnerabilities that I can apply. Okay. What else can I find out about the website? Okay. There's another website called showdown.io. It is an IoT search engine. It's indexed every device on the web. Not even servers, everything, because it's descended to do IoT. The good news is, for me as a bad guy, is that if I put the IP address in, I can get a whole bunch more data about it. The bit at the top is actually a map of where it is physically located. You can see roughly, look, there's Nginx 1.2.12. Because what Showdown knows is it knows how to ask the ports for certain data. So it knows what they are, so it'll pull that down. Okay. Okay. So that's cool. Now I can use Showdown the other way. I can just put technology in. So if I type Java and say, what have you got, what server out there run Java, I get a long list. If I look at one of those, log in. So look, real site, probably not on the list anymore, real site, server, Jetty 42.x, Java 1.6. I know how many vulnerabilities Java 1.6 has got. Okay. So I'm going to go looking for existing exploits. Okay. Showdown has an exploits page because, believe it or not, there is a whole set of people out there that are creating exploits for these vulnerabilities as their profession. So I go to Showdown and go, what exploits do you have for Java? And it prints me a load of them, and I just pick one. Okay. This is between PHP and Java. Cool, great, thank you. What about for struts? Oh, there's the RCE, the 2211 stuff. Okay, and some others. Thanks very much. These are coded exploits. And I'll show you one in a second. And then I can run the exploits because I have this tool, the exploit database, and these are all connected. And this is code to exploit the vulnerability. All I've got to do is change the target server, run that against the IP address of the server that I've just found, and I'm into your server. Is that cool? And I can do more. There are loads of other tools. This is a really neat little tiny one that I found that I quite like, called Wappalizer. It's a browser plugin. So I go to a website, in case Barclays, and I activate the Wappalizer, which is a little plugin, and it basically does the same sniffing that I did, but it's better at it. And it tells me things like, what am I running? What the server is? Apache, JavaScript frameworks, it's using D3, it's got site analyst, a whole bunch of stuff. So I go digging a bit more, and soon I have all sorts of information that that server has told me about it. jQuery 224, Adobe Experience Manager, what OS, what Linux is running. Thank you very much. jQuery, hey, a nice little vulnerability, right? So I go to SNCC, which is another website which does vulnerability management and other valuable things worth looking at, and it tells me about what jQuery's got. Or I go back to CVE, details, another website which keeps all the data. This one is really cool because this public website keeps track of the type of problem. So now I've got a little table, and one of the tables tells me what, look, there's a code execution table column. So I go, okay, so all I've got to do is I bring it together. Thank you very much. I know exactly what to use against you. Hey, you feeling vulnerable? It gets worse. Okay, do you remember this thing? Okay. The Equifax thing. Here's the bug. Okay. Here's the timeline. When Equifax got this, so March the 5th is when the vulnerability was announced and fixed. Okay. March the 9th is when the first who is run. Somebody had already figured out the exploit and was probing Equifax using that exploit. Bad guys get into your system and look around, and they don't want you to know, so they probe. And then there's 3 months of them stealing Equifax's data, and then July they finally figured it out, and then they went into crisis management, and by the time they finished, September, there was another one. Right? Which is scary, because you have to understand that this is not fly-by-night. These guys get into your system and stay there. But what it's really showing us is the time between the vulnerability being published and it being exploited is dropping. 2006, it was 45 days. 2015, 15 days. What do you think the number is today? How long have you got between a vulnerability being fixed, being published, and somebody knocking at your door to exploit it because you haven't fixed it? You have 2 days. That's it. Right? The bad news? Vulnerabilities are always going to, vulnerabilities is the way into the server. You have them, they're inevitable, they're based on bugs, okay? And the point is that if you don't fix them, you're going to get found. Because it's a whole industry out there of managing all that side of the business of discovery, fixing, exploitation, and it's all public. It's not dark. It's a business. People are making money out of this. Okay? And because we don't think about security, because we don't think about designing defensively, because we haven't had to do it before, we ignore it. And because we trust everybody, right, we just go, yeah, it's fine. But the bad news is it's just going to get so much worse. The good news is that if there is any, is that right now all you need to do is to be less vulnerable than somebody else. Because most of the time, it literally is that sort of flyby, that drive-by. They'll do those sorts of searches, they'll find you, they'll come in. If you don't have the exploit that they're using, they won't come to you because you won't show up on the list. So basically, as soon as the vulnerability comes out, you have to have it, you have to apply it. Because if you don't, you're likely to be attacked. So, I'm sort of running out of time. What else can you do to make this less of a problem? Well, there's a whole bunch of things. There's CWE, Related Sid's website, which has got coding practices for you as a Java programmer, common weakness enumeration. Okay, there's a whole bunch of classifications. You can go read loads of information about how to write better Java code so you are less vulnerable. Oracle produced one for, they have the secure coding guidelines. It's quite dry. It's got a nice section on serialization you can go talk about. There's a whole bunch of tools, loads and loads of tools, which you can apply to your code bases. You can apply tools to your dependency management. One thing like Sonatype do them, SNCC do them, everybody does them. There are ways of making sure that you discover your vulnerabilities quickly, right? There are specific tools to help you figure out whether your source code that you've written has got bugs in it. Okay? Loads and loads of online guides. Loads and loads of online guides. OWASP is an organization that keeps track of the most likely trends, what's being used to attack you. And you can go read about that. Okay? That's really cool. Right. Summary. It's not the greatest. You have to, number one, you have to keep all your Java instances updated. So your VMs have to be updated, your applications have to be updated, your dependencies have to be updated, your build processes have to be converted into a process where you can deal with this all the time. Because if you do not put on these patches when they get announced, you're going to get hacked. Right? And then things like, don't do silly things. Don't write custom security managers because that just bites you. Don't write your own parsers. Don't write, use modern protocols. Okay? Think about how the data comes into you. And I want to, this is an exercise, this is homework. I want you to go away and check what validation is done by file and path in Java. When you pass in a string, URL string or a file string, what validation gets used? Who does the validation? Who says that that's a valid string? Right? Who checks to make sure you can't escape out of your file system? You'd be surprised to see that it's you and not the system, because the system just does what you want. And people pass in data in forms that you weren't expecting and drive your code down different paths, because you assume that a lot of the protection is there and it isn't. At the end of the day, it's all down to developers. It's all down to you keeping yourself safe. The good news is things like microservices designs and things are helping us, because that's a compartmentalization technology approach that fits in. Because obviously if you can break your services into smaller services, Docker images and things, then it's harder for the bad guys to break out. Okay? But you have to think about how you design your software. If you're not thinking about being attacked, you're not thinking about the guy on the other end of the wire being unfriendly, and you just assume that they're always going to do the right thing, you're going to come off worse. So final plug, you can go to Adopt OpenJDK and you can get your free supported Java, OpenJDK plus Hotspot, OpenJDK, OpenJ9 or the SAP machine. The good news is they're built and tested by a community, and they are going to be there, and all the security fixes will be applied to that as soon as possible. And a whole bunch of vendors are standing up to saying, and we'll support it. Where support can be, we'll provide security fixes longer than somebody else, but also start to give you the ability to pick up the phone and ask people about how to get fixes in the JVM. And that's it. Whirlwind tour of Java vulnerabilities. Most of what I've said is actually applicable to things other than Java, because right now we're at the vulnerability high-level thing. The next level down about you learning to write more secure Java code, something you need to do. But personally, right now, the number one thing to take away when you go back is to think about your vulnerability management and what you're doing to make yourself less vulnerable by getting fixes applied as soon as possible. That would be your number one thing to do. And the second thing is to go and have a good look at how your validation logic and what assumptions you're making on who's giving you protection. And that's it. I'm finished. Thank you very much. Any questions? Oh, I like the echo. Okay, anybody happier than when they started? I wasn't quite sure. It's a scary subject. I'm here all day, so if you want to chat me later on, that'd be fine. Thank you.